Our learning target today is I can find the slope or average rate of change of a graph. We're going to first look at a linear function here. And when we're looking for the rate of change of a linear function, we're really just finding the slope. And the slope is constant in a linear function. It doesn't, that rate doesn't change. And I just need 2 points on my line, an x and a y, and a second x and a y. There we go. My pen tool there wasn't working. Okay, so here is my first point that I'm going to use there, that y-intercept, and that point is at 0, 3, and then the second point is at 2, 0. If I label those, this would be like my x1 and my y1 and my x2 and my y2, and I'm simply going to substitute those values into the slope formula right here. So my y2 was 0, my y1 was 3, so 0 minus 3, and then my x2 is 2, and my x1 is 0. So when I simplify this, I get negative 3 over positive 2, which is negative 3 halves, or if you write this as a decimal, it would be negative 1.5. I noticed that this was downhill, so the fact that I got a negative slope makes sense here. Now, when we're looking at a quadratic function, we're not finding a slope or just a simple rate of change because it's not constant. We're actually finding the average rate of change between 2 points. They're going to give you 2 points. Here we're using x equals -1. So when x is -1, this is the point I'm looking at, -1, -4. And then my second point here I want to use is when x is 1. Well, when x is 1, y is 0. So those are my 2 points, x1, y1, x2, and y2, and I'm going to plug them in. It's the same formula. It's the change in y's over the change in x's. So my y2 was 0, my y1 was -4. I'm plugging in a negative. Yes, there's a minus sign, so there's 2 negatives there. That's important. Then my x2 was +1 and my x1 was -1, so minus a -1. If you'll remember, when you have 2 negatives, this turns into a positive, so that's going to be +4. And then here I'm going to have 1 plus 1 or 2. 4 over 2 is just 2. So my average rate of change between these 2 points is +2. And that makes sense here because from here to here, look at, I'm going uphill, so it makes sense that I get a positive answer. And then lastly, we have our exponential function. We do it the same way we just did quadratic functions. They give us 2 values that we're trying to find that average rate of change between. So when x is -1 on my function, my y value here looks to be about 1/2. And then my second x value they give me is 1. And when x is 1 here, my y value is 2. So if I label my points x1, y1, x2, y2, then we plug them in. So my y2 was 2 and my y1 was 1/2. And then my x2 was 1 and my x1 was -1, so minus a -1. So when I go to simplify this, 2 minus 1/2 is 1.5. And then I've got 2 negatives here, so 1 plus 1 would give me +2. And then when we simplify this, we ended up with 0.75, or if you are using fractions, we would have gotten 3/4 for our average rate of change here with our exponential function. If you need some more information on this topic, you can check out your Learning Target spreadsheet for additional resources, videos, and practice.